Hey YouTube, in this video we're going to take a look at a problem I was given by an apprentice I work with which relates to relay logic. If you're not familiar to relay logic and how relays and ladder diagrams work, take a look at my previous video. The problem gave this ladder diagram and a set of specifications that the diagram must meet after it's been modified. To start, I'll go over the operation of this original circuit. On rung 1 there is a dual voltage relay, which I will explain a little later, the Z1 high voltage contact related to that dual voltage relay, and a reset button. On rung 1A there's initiating switch, which would be a fire alarm pull station, and on rung 1B there is the end of line resistor. Rung 2 has another Z1 high voltage contact which activates a red light, and on rung 3 there's another Z1 high voltage contact which activates the relay signal contactor coil. Rungs 4 and 4A have normally closed low voltage contacts from dual voltage relays, which are used to activate the yellow light and buzzer in the trouble indication circuit. Rung 5 has another dual voltage relay, the supervisory contactor labeled SS, and a pair of contacts, one normally open and one normally closed, from the signal contactor. Rung 6 has another pair of contacts, normally closed and normally open, from the signal contactor, which are used in conjunction with the contacts on rung 5 to activate the signaling device, which you can see in series with a diode and in parallel with another end-of-line circuit monitoring resistor. The dual voltage relays have two coils which can activate two different sets of contacts. There's a low voltage coil, which is activated when power from the 24 volt supply passes through a resistor and then through the dual voltage relay, as well as a high voltage coil which only activates when the full 24 volts passes through the relay coil. When power is first applied to this circuit, current passes through the end-of-line resistor on rung 1B, dropping the voltage. This current then passes through the relay Z1, opening the contact Z1 on rung 4A. On rung 6, 24 volt power passes through the end-of-line resistor in the signaling circuit and then through the low voltage coil of the dual voltage relay SS. This opens the normally closed contact SS on rung 4, preventing the yellow trouble indicator light and buzzer from being activated. Notice that the signaling device on rung 5A is not activated because it's in series with a diode, which is at the moment reverse biased. In an alarm condition, the initiating switch on rung 1A will be closed. This makes the high voltage coil of relay Z1 active, closing the contact Z1 on rung 1. This means even if the initiating switch is open, the high voltage coil of relay Z1 will remain powered. On rungs 2 and 3, the high voltage contact Z1 are also activated. This causes the red light to turn on and the signal contactor coil to be powered. Once the signal contactor coil SC is powered, the SC contacts on rung 5 and 6 change state. This allows 24 volt power to enter through rung 5, pass down through the signaling device, whose diode is now forward biased, and then out through the normally open contact on rung 6. With the normally closed contact SC on rung 5 open, no current passes through the supervisory contactor SS. This causes the normally closed contact on rung 4 to close, turning on the yellow trouble indicator and the buzzer on 4A. In a trouble condition, the wiring in the initiating circuit or in the signaling circuit is broken at some point. This means power does not pass through the end-of-line resistor and to the dual voltage relay. In this example, power stops at the end-of-line resistor in rung 1B. This causes no current to pass through the dual voltage relay Z1 and for the normally closed contact on rung 4A to remain closed, allowing the yellow light and the buzzer to be activated. Trouble in the signaling circuit results in a similar operation. A break in the wiring of the signaling circuit prevents low voltage current from passing through the supervisory contactor SS. This causes the low voltage normally closed contacts SS on rung 4 to remain closed, activating the yellow indicating light and the buzzer on rung 4A. The problem asks that a second initiation circuit be added with a relay Z2. It also asks that a trouble silence push button and relay be added, TS, and that an alarm silence push button and relay be added, AS. The following notes were also included. AS and TS should be reset by the existing reset button. The initiation Z2 should have its own alarm light. The silence buttons should only silence the audible signals, and that the silence features only work when the audible signals are active. You cannot preemptively silence the audible signals. Starting at the top of the ladder diagram, here's a list of the modifications that are required to make the old circuit meet with the new specifications. On rung 2, 2A, and 2B, a new initiation circuit is made, which is a perfect copy of the original initiation circuit, except that it uses a new relay, Z2. On rung 3A and 4A, an alarm silence and trouble silence circuit are made. These consist of a latch, which are activated by push buttons, and a pair of normally open contacts, SC and TSR, which are used to prevent you from activating the alarm silence and trouble silence if the alarm or trouble is not currently activated. Rung 6 contains a normally open set of contacts for relay Z2 and a red light as an alarm indicator for the second initiation circuit. On rung 8A, a normally closed contact, TS, is added to the buzzer line in order to silence the buzzer. On rung 8B, a normally closed contact, Z2, is connected to the low voltage coil of Z2. This indicates trouble on the Z2 initiating circuit. Also on rung 8B, there is the coil for TSR. This is the trouble silence reset inhibitor. If there is no trouble indicated, you will not be able to latch the trouble silence circuit. Finally, on rung 9A, there is another set of normally closed contacts, AS. These work from the coil AS in the alarm silence circuit. When the alarm silence circuit is turned on, these normally closed contacts on 9A open, silencing the signaling device. When power is first applied to this new circuit, the low voltage coils of Z1, Z2, and SS are all active due to the end-of-line resistors. This prevents the trouble circuit from being activated. If you were to press the alarm silence or trouble silence push buttons at this point, there would be no reaction, as the contacts SC on rung 3 and TSR on rung 4 are open. Similar to the operation of the original circuit, if the initiating switch on 2A is activated, this will cause the high voltage coil of Z2 to be active. This will close the Z2 contact on rung 2, latching the alarm in the on state. This also activates the Z2 high voltage contacts on rung 6 and rung 7A, turning on the circuit 2 alarm indicator and the signal contactor, SC. With the signal contactor SC activated, the SC contacts on rung 9 and 10 change state, allowing current to pass through the signaling device. This also stops current from passing through the supervisory contactor SS, allowing the normally closed contacts SS on rung 8 to close, turning on the yellow light, the indicating buzzer, and the trouble silence reset inhibitor, TSR. Now that the circuit is in an alarm state, it is possible to use the alarm silence circuit. Pressing the push button, alarm silence, on rung 3 allows power to pass through the now closed contacts SC and through the coil AS. This latches the contacts AS on rung 3A on, keeping the circuit activated once the alarm silence button has been released. This also causes the normally closed contacts AS on rung 9A to open, silencing the signal device. If the reset button on rung 1 were to be pushed, current would be stopped through the coil AS, resetting the alarm silence circuit. Trouble in the new initiating circuit is handled in the same way as the original circuit. If low voltage power can't make it from the end-of-line resistor to the dual voltage relay Z2, then the normally closed contacts on 8B will remain closed, allowing power to pass to the yellow indicator light, the buzzer, and the trouble silence reset inhibitor coil. If the treble silence push button on rung 4 were then to be pushed, current would pass through the now closed contacts TSR and through the coil TS. This would latch the relay TS in the on state because of the contacts on rung 4A. This also opens the normally closed contacts on rung 8A, silencing the buzzer. To reset this circuit, the reset button on rung 1 can be pressed, stopping current from flowing through the coil of relay TS. Relay logic is a cost-effective way to automate simple tasks, but has been steadily phased out since the invention of PLCs, programmable logic controllers. I hope you found this homework problem interesting, and if you'd like to see more like this, check out my channel. Thanks for watching.